Now that we know how to simplify rational expressions, we can multiply rational expressions. Before we begin with the variables, let's look at if there were no variables, just a fraction times a fraction. You could multiply straight across the numerator, straight across the denominator, and then simplify that result. Or we can simplify first, divide out any common factors from within the same fraction or from one fraction to the other fraction, and then multiply what's left. And that is actually easier. It's easier to make it smaller before we make it bigger, before we multiply. We're going to do the same thing here. Do not try to multiply these. This would be a large polynomial. A 2 or a binomial being multiplied by a trinomial is going to end up a large polynomial that we'd have to still factor to simplify. So before we multiply, we will factor and divide out all the common terms. So let's go ahead and look at this first example. I have to factor everything. So each expression, rational expression, the numerator and denominator as far as possible. On the left, I can take out a 7 from that numerator. Then I would be left with x plus 1. The denominator is factored as far as possible. I move over to the next fraction. I want factors that are going to multiply to negative 20 and add to negative 1. So 4 and 5, and I'll put the negative with the 5 to add to the negative 1. The front coefficient is 1, so I go directly into my factors of x plus 4 and x minus 5. In the denominator, I see I have a GCF that I need to pull out first, and then take out a 7. That leaves me with x squared minus 6x minus 7. And then I need to factor that second denominator a little bit further. So let me just copy down everything else first. So I still have that GCF. And then I want factors that are going to multiply to a negative 7 and add to negative 6. I'm thinking the only way to do that is with a 1 and a 7. And if I want it to add to negative 6, I need the negative to go with the 7. That will multiply to negative 7, add to negative 6. The front coefficient is 1, so I go straight into my factors of x plus 1 and x minus 7. Once everything is factored, I divide out common factors. Something from the numerator and something from the denominator. They have to be identical. So x plus 1 divided by x plus 1. Something from the numerator, something from the denominator. I could also do an x plus 4 divided by x plus 4. Those common factors divide out. And then lastly, I also see a 7 divided by 7 can be divided out. Once everything's divided out, you multiply anything that's left. So in the numerator, I only have x minus 5 left. In the denominator, I have x minus 7 left. And that is as far as you can go. Go ahead and try the 2 on the right. Looking at this example here on the right, I have to factor all 4 places here of the numerator and denominator from each rational expression. I'm going to start here in the left rational expression in the numerator. This looks like it's 2 terms. There's no GCF, but they are a sum of cubes. So what is being cubed? X is being cubed, and 3 is being cubed, right? 3 times 3 times 3 would give me 27. The way we're going to factor that is with the sum of cubes formula and remembering SOAP. Same sign, opposite sign, always positive. So I begin factoring with just an x plus 3. I keep the same sign. Then I square x. X times x is x squared. Then I do the opposite sign. I multiply the two terms together, 3 times x, always positive sign, and then I square 3. 3 times 3 would be 9. That's as far as we can go. Then in the denominator of that rational expression, I see my leading coefficient is negative, so I'm going to take out a negative 2, because the GCF is 2. When I take that out, I'll be left with a positive x and a positive 3, right? Negative 2 times positive 3 would give me the negative 6. In the right numerator, that is factored as far as we can go, since it's already multiplication. In the denominator, I want factors that are going to multiply to 9 and add to negative 3. I don't think that's possible, right? The only factors of 9 would be 1 and 9, or 3 and 3, and neither one of those are going to add up to negative 3. So that's prime. I cannot factor that. But I notice that I actually have this whole factor here, x squared minus 3x plus 9, is the same thing as x squared minus 3x plus 9. That is a common factor that will divide out. I can also divide out an x plus 3 and a factor of 2 from the 4. So the only things that are left in the numerator are 2 and an x cubed, and the denominator a negative 1. So 2x cubed divided by negative 1 is the same thing as negative 2x cubed. So that whole thing simplified down to negative 2x cubed. In this next one, same thing. I always start with the GCF. So on this left rational expression in the numerator, I see a 5 in common. I'm going to go ahead and take the 5 out. I would be left with x squared minus 2x minus 3. In the denominator, they both have an x squared that I can take out, and I would be left with x plus 1, right? X squared divided by x squared would be positive 1. In the numerator of the next one, I can take out an x squared as well. I'd be left with x minus 1. And then in the denominator, I want factors that are going to multiply to negative 6 and add to negative 1. Oops. So I'm thinking 3 and 2. One of them needs to be negative, but I want it to add to negative 1. So I'm going to put that negative with the 3. Since the front coefficient was 1, I can go right into my factors of x minus 3 and x plus 2. I still have one more thing to factor over here. So in this one, I want factors that will multiply to negative 3 and add to negative 2. The only factors of 3 are 1 and 3. And I want to put the negative with the 3 so it can add to negative 2. Again, that front coefficient is 1. I go right into my factors of x plus 1 and x minus 3. And then that is completely factored for everything. Just going to copy down the rest of it. And then see what will divide out. Remember, the signs and terms all have to match. So I can take out an x squared and x squared. I can divide out x plus 1 divided by x plus 1. x minus 3 divided by x minus 3, and I believe that's it. So multiplying anything that's left, there's a 5 left, and an x minus 1 in the numerator, and in the denominator I have an x plus 2. So you could leave it like that, or you could distribute that negative 5, or that 5 through, and get 5x minus 5 over x plus 2. I think I'm going to write that a little bit better. So 5x minus 5 divided by x plus 2. Either way. And that's how we multiply rational expressions. You factor everything, all the numerators and denominators, look for common factors, divide them out, and then multiply the result.